This Hangout's live.
Now it's live.
What is this? What are we doing? Where are we here?
Well, I can't answer that question. It's a little bit too existential for right now because right now is show and tell time, where we don't ponder the meaningless of life. We actually show off our maker projects, your 3D prints, your cosplay, your electronics, all the things that you're building, you're working on, you finished, maybe didn't even work out. Come by and show them off. We do this every single Wednesday at 7:30 p.m. Eastern time. I'm Lady Ada. This is Mr. Lady Ada. We're here in the Adafruit factory. We've got this like really nice Xerox printer here, and there's my workbench covered with crap and future products. And we're going to start off with Noah and Pedro.
And Pedro, what you got printing this week?
Hey guys. Hello everybody. Happy Wednesday.
Happy Wednesday.
So this week we released an updated version of our camera light ring. So
That's nice.
3 years ago maybe?
Yeah, this is the old one.
Yeah, so this just attaches to the DSLR camera, but our new updated version, since everybody just now live streams with their iPhone, is updated
Or Android phone.
or Windows phone. Yeah, whatever mobile phone.
Yeah.
So
This is right.
yeah, so we got some really cool new NeoPixel LEDs in the shop. The rings have an extra LED in it. It just does weight. So we're able to, instead of trying to combine red, green, and blue, we can now just have a dedicated white light. So we added 2 NeoPixel sticks on the end to elongate it so we can fit even the fattest phone on there. But you don't have to use it with the phone. You can just use it as a standalone light ring as well. And then we got all of the
usual warm or neutral white LEDs?
So this one is the neutral. We do have the warm and the cool ones in case you want to use a different temperature for that.
Yeah.
So we do got those in the shop, but this one is of course just using all of our usual suspected camera little connector parts. So we have the 3/8 to 1/4-20 converter and the little swivel head on there. And it's just a trinket and a LiPo backpack charger and a 2500 milliamp hour battery that slots in there. Everything's completely modular, so you can attach like a GoPro up to it or just have it on a tripod to light up your scene that way. And then
I think it's cool that it's an oval. I haven't seen a light ring that is an oval shape, so it's kind of neat that you can kind of throw in a pixel PCB, a stick PCB in with the quarter.
Yeah,
the quarter 60 PCBs.
And I went a little bit different with the mounting on this one. So you can poke your own mounting holes in there. So you can add a feather board or any other updated board that'll come out to control the LEDs.
I'm digging it.
Yeah, so we talked about it this week on earlier today on 3D Hangout. So you can check out all the fusion techniques that we use to model and build all of this and do the 3D printing. And Noah, you got yet another fidget spinner.
You want me to show that? I milled out a fidget spinner out of acrylic. So that's it. Using the 608 ball bearings, and it just looks nice in acrylic. So I used the Other Mill Pro to mill this out. Just 2 pieces sandwiched together and nice little chamfer on the edges.
I love how it's so addictive. Like once you get into fidget spinners.
I am a fidgeter. I literally am a fidgeter, and I do this all day. So
it looks fun. It looks fun.
I like that you've both drifted towards addiction projects because we all want to take photos of ourselves with our phones, so it should be, well lit selfies. And then, if you're gonna fidget, you should at least make your own fidget devices. I saw a video where someone took an air hose because they wanted to fidget it even faster.
Yes.
And then, they let it go and it sparks and all that stuff.
Yes.
Yeah.
Jerko, whatever. Yeah.
All right. So we'll play at least a couple of those videos tonight on here.
Please do.
All right.
All right, guys. Thanks.
Y'all.
Fidget away.
Tony D, what you got going on?
Hey, yeah, sorry, been a little while since I've been on show and tell. I had to fix the arc reactor, so got it all tuned up. It's working really well, but actually this is a Seattle Comic-Con project I'm going to work on. It's in, I think, like 4 weeks or so, and I realized, oh, I should probably do something. And I've got the world's simplest cosplay project, so it's just going to be the arc reactor. Now, I'm sure I'll see a lot of arc reactors there. It's a pretty popular thing. But how many are going to be something like this? This is the SAMD21 Circuit Python or Circuit Playground board. So I'm hoping to do that version on my shirt like this. So my Circuit Playground, my arc reactor is going to run Python, which is going to be kind of cool and set myself apart from other folks. And then just real quickly too, I did a live stream last week of the ESP32. So this is the fancy new successor to the ESP8266, and how to run MicroPython on it. So check out the YouTube videos and channel to see that video. I just show you, you have to compile the firmware yourself right now because it's still pretty much in active development, but it's not too hard. You can set up a little virtual machine, compile it, load it up, and get to the REPL, and like I blinked an LED with it. So do the basics with MicroPython. I'm sure in the next year we'll see a ton more stuff, and like Damien's working now with PyCom and all kinds of folks. So ESP32 should be pretty exciting. And I tried it out also with Arduino, the Arduino ESP32 port, and that works great too. So I think this is going to be the year of the ESP32 for sure.
Outstanding. Okay, and the name of the event that you're going to for the
the Emerald City Comic-Con. It's Seattle's big Comic-Con, so it's March 2nd through 5th, I think. And I think I'll be there that Saturday. It's like the tickets sell out literally the day they go on sale a year ago. So you're lucky to get one ticket. So I'll be there.
Who's in the area can go see the world's first Python-powered arc reactor.
Exactly. Yep.
All right, thanks, Tony.
Cool. All right, thanks, Tony D. Next up, John Park, what you got going on this week?
Hey, I've got a little robot that I'm working on, and this is called KiriBot. KiriBot is going to be a new version of one of our 3-layer bots that we'll be offering in the store, and this one uses the Arduino 101, the Intel Curie-based Arduino 101. It's pretty cool. It's got Bluetooth built on, so I can control it from the little Blue Fruit LE app. So you can use the little, I'm not going to drive it around and crash it, but you can use the little arrow keys here to drive around. And I'm doing some little extras for the guide. So I've got a little Pez dispenser powered by a micro servo here, running off of the motor shield.
Candy. Everybody some candy.
Have some candy. And this is the prototype one where I'm using an Iron Man Pez, but I found out, for anyone who's super knowledgeable about Pez, there's this form factor of Pez that's usually not available in the US. I don't think it is, at least. It's mini-sized. So there's like Mario ones in Japan and all kinds of crazy stuff. I'm going to avoid looking at it because then I might end up on eBay buying it. But you can get this Trolls from the Trolls movie set, which has a really nice, short little body. So I think I'm going to try to modify our...
Is the candy the same size for those?
Say again?
Is the candy the same size for the...
Same size candy, yeah. Same size.
Just half.
Yeah, okay, got it.
Just a shorter neck, which I think will be cool.
Okay, yeah.
And I also, on this one, have put in a little bit of underlighting. So in the Blue Fruit LE app, I can go and switch over to the color picker. Go vertical for that. And I'll put these things from the camera. So we can go and choose a color and light up the underlighting.
Nice.
See that?
Yeah, that's blue.
A little better. So we're going to have some really styling neon 1990s style underlighting underneath the Adabot. And that's the project. So I'm working on a guide that'll be coming out soon. And we'll also have a video a little bit later. So stay tuned for that.
All right. Outstanding. And thank you with sticking with the Make Robot Friend. That gives you candy, not robot enemy.
I like it's robot friend.
All right.
Candy.
Next up, Eric. Eric, unmute your mic and show us your project. What you got going on, Eric?
Hey guys, working on a LED display over here with a 600 neopixels for my dead mouse helmet.
This is great.
There we go.
Whoa.
Yeah, so that's 600 LEDs being powered by the Feather Adalogger, and I have all the animations saved up on the SD card.
Wow, we're only getting a couple of frames because I think you're on your phone, but it's still impressive.
Yeah, no, it's like roughly
Gee.
like 25 frames on, well, for me seeing it live.
Wow.
Are you using like the processing, like the fade candy? Like we did a demo once on how you could take processing output and then save it onto an SD card and replay it. Are you doing that, or did you manually index all of these LED strips?
I manually indexed all of them, and then
Yay.
I just inputted it into Arduino. But yeah, these the ears are 3D printed, and then this display up here, that's just a laser cut acrylic, and all the wires are being routed down here.
Yep.
Cool.
Across each other through like a Raspberry Pi cobbler, and so I could separate them when I need to take them off the helmet and put them back on.
All right.
This is outstanding. Well, as you get close to finishing it, please send us photos and more. And of course, email support@adafruit.com. We'll send you an as seen on the show and tell sticker. And if you want to document it or do anything, let us know. This might be a fun thing to get on the Adafruit learning system or whatever. And I could probably get you some gear to offset some of your price. With 600 neopixels, you probably spend a bunch. So maybe we can help you out and give you some.
I'm also going to do the face itself, and that's gonna use twice as much.
Okay.
But
maybe we can catch you a deal.
I think I was. All
Do
right,
you
sounds
check
great.
out the Lightship tutorial? It's called Lightship, and it's on Learn, and it's a Phil B tutorial, and it shows how you can basically you can model the NeoPixels in processing, and then play any video you want, and then save the output. So if you want to have like you basically you can play videos, or you can have animations that you download from the internet, and then you can save them to the SD card and then replay them, and it will do all of. I mean, like you got it working, but if you wanted to like do live streaming video, you can do it over Wi-Fi.
Oh, that's cool.
Okay.
I'll definitely give that a look.
You got the ears. You're ready to go.
Well, Eric, email support@adafruit.com for the sticker, and if you want to cut some deals, I'm PT at Adafruit.
Yeah, you send me some hardware.
We'll work out a deal. That's exciting. All right.
Yeah.
Thank you so much. Next up, Matthew. Hello, Matthew. Unmute your mic and show us your project.
Hi, can you hear me?
Yeah, you sound good.
Oh, hi. Hello. Hi. Yes, I'm Matthew, and I'm here in my lab at the North Carolina Museum of Natural Sciences. This is the Visual World Investigate Lab. I teach a lot of classes here, and one of the classes I teach is climate change. I want to do something really special for that to make it very unique and memorable. So in order to do that, I decided to, instead of showing photographs and videos of everything in my presentation, I use virtual reality. And
that's a good
to
idea.
do that, I use headsets that I made. So I have 10 of these. This one's not on right now, but I do have some that are on. I used your old plans that you used to have on your website as a starting point a year or so ago. And from there, I created the headset from scratch in Blender. I used one of your screens. I'm using a Trinket Pro right there. I've got a serial to USB adapter, just a cheap one from China, and one of your 9DOF sensor board.
Yeah.
There's also, here's one that's on. There's also, of course, lots of LEDs. I've got a NeoPixel ring in the middle there. And that dark spot in the middle, that's a really good webcam. So this can do augmented reality as well. So I can do both. And initially I'd written everything in Unity 3D, but I recently changed over to processing. Everything's just done in processing. It works really, really well. So I can do 3D model scenes, but I primarily use videos, 360 videos in these to drop the kids off on top of glaciers or at Mars.
That's neat. So they can see like it's melting, polar bears are like putting on sunscreen, all sorts of stuff.
Exactly. So I thought you might. I don't know how many people you've heard of using your tutorials to start something, but it helped me an awful lot. And we get a lot of people in here, and your site is the first place that we always send them every day for all the great tutorials and products.
Yay!
I really, really appreciate it, and quite happy with them.
Glad
Thank you so much, Matthew. Well, no matter what, email support@adafruit.com so we can send you an As You Know on the Show and Tell sticker. And if you want to email me, pt@adafruit, send any information about your lab and the things that you're doing or any photos, and we can put it up on the blog. One of the things that we found is if we do a tutorial and then someone makes something cool and then we post about it, then more people, because there's people like you in other labs, other museums, other places that are just looking for a place to start.
That would be great.
Yeah, we'd love to help out. And you can use it for anything. I mean, in New York, we have the Museum of Natural History. It'd be cool to have them have headsets that they make where you can see some of the animals instead of them staying still, maybe augmented reality.
Exactly. And I could have bought these. I mean, I probably could have used some cheap phones and gone that way. But I've found in my lab that one of the first questions that kids always ask when they see a bit of technology in here is did you make this? And so 99% of the time I'm able to say yes. And then they completely light up, and then they have a whole other set of questions. Yeah. So it's a great effect.
It's like you're teaching science and you're teaching engineering because they can imagine making some of that stuff.
Exactly. And everything's exposed with everything this and everything.
Yeah, I like the skeleton look.
Yeah.
Well, the reason why it's skeletal is I wanted to use as little plastic as possible. And I'm not totally interested in making it completely 100% immersive, like you're actually there. I think of it more as like a window, like a portal. You're looking to like another place. So it works out.
Codename Oculus Arctic Drift.
I've heard some people call their homemade Oculus as Oculus Thrifts.
Oculus Thrifts. All right. Well, thank you so much.
I appreciate it.
That was a great demo. All right.
Yeah. Okay. Got Lon and
Next
Aiden.
up, hey Lon, how's it going?
Hey, Lon. Welcome back.
What you got going on?
All right, so more ray guns and space guns and that sort of thing.
Yay!
So I'm working on a replica prop. Oops, I gotta do window sharing. Screen share. So this is from Rick and Morty. It's the antimatter ray gun that is sold to Krabopulus Michael. And then this is my blueprint. And get the screen share back off. My back.
Not yet.
Screen share. Oh, there we go. So I took my blueprint and just to make sure I had the scale right, I made a 2D profile version of it in cardboard. And today I'm making another, this time cardboard and foam version.
That's cool.
So this is basically the same, using the same template, but in profiles, and then I'm building up with a pink insulation foam. And then when this is done, the plan is to rebuild it again. Now that I have the scale and all the parts worked out, I'm going to print out 3D ribs for the, on 3D printer, I'm going to print out the ribs for this top part, and then fill that full of clay, and then use that as a positive buck for vacuum forming, because it's all clear parts up there. And then all the flat planes are going to be made out of PVC foam. And then when that's all built out, then I'll mold and cast that in resin. So I'll have resin parts for all the solid pieces and vacuum form parts for all the clear pieces.
Cool.
But yep, that's what I'm working on tonight.
Okay.
Very cool. Well, you get a sticker, you know how to get a hold of us. That being said, we saw a movie not too long ago, and it reminded me of some of the stuff that you do. It's called Superman Lives. It's the story of the Nick Cage version of Superman that never came out, and they have a whole section about vacuum forming plastics
And how they made
and
the
how
suit.
they did it and how they made the
LED
suit. So
cool.
I think it's on whatever downloadable Hulu-like Netflix thing, but check it out. And if you scrub through, if you even don't want to hear the history of that Tim Burton Nick Cage movie, the costuming is really cool.
Yeah, vacuum forming is a great way to make lightweight armor and stuff.
Yeah, that's what they did.
Yep.
All right. Thank you so much. All right. We're going to keep moving along. We're going to go to Aiden, then Sally, and then C. Scott. So let's see how.
Aiden, how
how's
you
it
doing?
Hi. So a while back, I was reading some old geometry papers from like the 60s, and I'd come across one by a Swedish mathematician by the name of Borge Jessens about a interesting 20-sided shape that was considered a unstable icosahedron. So obviously, I had to go ahead and make the shape myself, and I designed it all and 3D printed it. And it's
called an unstable.
Yeah, its official name is Jessens orthogonal icosahedron.
Right.
And it's got a lot of interesting mathematical properties. For example, if you connect the center of a few certain triangles, it'll make a cube, and a bunch of other properties like that. But the most interesting property is a physical property in that it's unstable, so that when it's squished, it compresses in all directions. So maybe you can see this on this one, but you can probably better see it with this bigger one, where if I squeeze it, it folds up.
It folds into like a cube.
It actually, the shape it squishes into is a octahedron. And so it goes from being a 20-sided shape to an 8-sided shape by just being compressed like that. And as a result of that, it very easily changes surface area and volume. And it has another cool property as a result of all of that, in that when it's compressed in any one direction, it compresses in all directions simultaneously. And that's a material property called being auxetic. And so kind of just a fun structure, and I thought it was cool to replicate this work, as there hadn't been a lot of other research on this topic of this shape besides the original research paper. So it was just kind of fun to play around with, 3D print, and make it real.
Is there a way to make it like the opposite, where when you expand in any, like, can you make, instead of a compression, make an expansion object?
Yeah. I'm not really sure about that. I've been experimenting with making this shape in a compressed form and inflating it in order to make it fill out. But I'm not really sure. However, I have been investigating other unstable polyhedra that have similar properties.
All right. Well, as always, email support@adafruit.com. Also, if you check Instagram/vvolverApp, they have an account and they just did a little video. You won't be able to see it that well, but they always post neat stuff, and it's flexible 3D material from designer Hiroshi Sugahara, and it's a ready to crawl. So they print out things that are very organic, and I thought of your work. So
yeah, I believe I had seen that post. It was very cool work.
Yeah, I was like, oh, I thought it was yours. I was like, this is neat. All right, well, thank you so much.
Thank you.
All right, Sally, and then see Scott will play us out. Sally, what you got going on?
Hey, Sally. Good to see you.
Well, hi, how are y'all?
Good.
I started something which you can see here,
That's nice.
Oh, yeah.
and then it's currently, if it works, yeah, there it goes.
Woo!
Oh.
It's
I
currently
get
running.
currently, haha.
At the moment, it's running the strand test, and so I've got to do a bunch of stuff and finish it and solder some more of these things. It's made with a NeoPixel strip, so it's fiddly soldering.
Yeah.
All those angles and stuff. But I just thought, in terms of what's going on in the world in my life these days, this was appropriate. And
Absolutely. It's an excellent time to make cool art.
Yes.
You can work to protest into your local makerspace and to show and tell.
Yeah, I'm covered.
Weddings,
a bunch
to
of them.
funerals, to bar mitzvahs, all sorts of things.
Well, it looks awesome.
So this is I'm going to say this is like going to be a time lapse. This is the before. So can you come back when it's?
Oh yeah, I'll bring it back when I'm done.
Okay.
All right. Stand up on the stool again, and you can see it on me.
All right. And is this your new craft room that you're working on before? Is this?
Yeah, it is.
It looks great.
At some point, I'll give you a tour of it. It's not unpacked yet, so it's somewhat disorderly, but
everything's a work in progress.
Yes, everything's a work in progress.
All right.
But I will show you the ceiling.
Oh, that's nice. You got a little skylights. So you get
cathedral ceiling and skylights.
Big light, the big windows.
Yeah. So the light up here is utterly fabulous.
You're one of the few people that I know won't make a craft room go to waste. I've known people like, I have a writing room, and they're like, they never finish their book, they never write anything good. But you're actually going to use this for.
Well, before I unpacked it, I'd started 2 new projects. So, yeah.
All right. Well, email us support@adafruit.com if you want a sticker.
Oh, we'll do that. Thank you.
All right. See, Scott, play us out. What you got going on?
Hey guys, hear me all right?
Yeah.
Okay. What you see on the screen there, this is the graph of a hyperbolic tangent. And I'm showing this to you because we also in the audio industry refer to this as soft clipping. Instead of coming up and smacking into your voltage rail, you get it to gently curve. This avoids that really harsh crackling noise like you get with an overdriven speaker or amplifier. Well, the reason I'm showing you this is because I'm making yet another module, and let me flip over to the circuit for you. This is the schematic for it. This is a voltage-controlled amplifier. You have a volume control buffered through your current sink, and it runs this. This is a transconductance cell. Just think of it as a voltage-controlled variable resistor. The trick, though, is this diode ring and this diode pair execute that hyperbolic tangent function, so that when you overdrive the input, you can bring a mixed audio input. There's 2 channels left and right. You bring mixed audio input in, and as it approaches the supply limits, it's actually limited to 1.2 volts below it, because op amps do phase reversals. Certain ones do phase reversals. You approach their rails. Anyway, instead of getting a really harsh, unmusical sound, you get this nice blended. Oops, I didn't mean to start that. Here, let me see if this works. I can't play it in heavy C, but if people want to play that, and that's a pretty powerful sound, so if you've got headphones on, beware.
I don't know what's gonna happen if I click this, so sorry everybody else.
It's just a filter sweep sound, but this is how that sounds in action. So this is 8 voices all being mixed through a pair of these hyperbolic tangent VCAs. And I should mention the technology is not new. It comes from, let me switch back to me. It comes from extending the headroom for analog tape recording because tape saturates in a way very similar to the hyperbolic tangent curve. And so they would develop preamps that drive the tape head a few dB above what would be considered clipping, and they would depend on the magnetic properties of the oxide on the tape to finish the curve for them. So this is my recreation of that. And like I said, I'm turning it into a module. You saw the schematic. Let me see if I can quickly bunch down here to the, yeah, here we go.
It's a digital version of like a chemical property.
But here we go. Yeah, here's the board. There's 2 boards. This is the one with the actual VCAs on it. The other one is a bunch of, I can't fit all the controls on there at the same time, so I put it on a second board. You just sandwich the 2 together with some board locks. And
Eagle 7.3, he's safe. He's safe.
Yes, yes. I actually looked. Eagle 7.7 is also fine. Anything below 8 is stuck with the CAD soft perpetual license. So if you've got a pro version or whatever version, then you're good to go. And as a parting shot, DigiKey sent me, the gauntlet has been thrown, guys. They sent me this awesome.
No, we told them to design it.
You know what? I feel really good about this because when they first started working with us, they wanted some ideas on stuff that their customers would like. They said, hey, we have these rulers. So we made a DigiKey Adafruit one. And they're like, this really worked out well. Do you mind if we do other ones? We're like, no, absolutely. And I saw a bunch of tweets today. This is a really cool ruler.
Yeah, they sent one.
It is very good because it has the kind of things I would expect on a ruler. It has both in mils and in millimeters, it has the power derating of current through traces of varying.
Yeah, they went nuts.
Yeah,
this is really important for people to follow when they're like putting out power traces and whatnot. And while digging through a box today, I thought Limor would get a kick out of this. I found 5 bags of my 2SC 1583 and 2SA 798.
Oh,
I really used these about 15 years ago. But
wow.
All right.
Anyway, that's it for me. I'll show you the actual module when I have it built. So
okay. All right.
Match
well, thank you, everyone.
I'm shivering.
We're here every week, 7:30 p.m. Thank you so much for making this our favorite half hour. It's been crazy, but this is the best half hour.
Yeah.
Thank you, Tony. Thank you, Sally. Thank you, Noah Pedro. Thank you, Matthew. Thank you, Lon. Thank you, John. Thank you, Eric. Thank you, Scott. And thank you, Aiden. And it's magic. What's the name?
Octagon. It's 20-sided unstable
an unstable icosahedron. All right. We'll see everybody on Ask an Engineer.
From Tron. No.
Yeah,
yes.
Maybe.
Maybe.
All right. We'll see everybody on Ask an Engineer in a couple of minutes, and we'll see you next week. Bye-bye. Thanks, y'all.
Cheers.